Okay, let's talk about quadratics and what types of problems that you encounter when you're dealing with quadratics. You have problems in which the problem says factor and solve. So those are the two types of problems that you'll see when you're dealing with quadratics. Okay. Quadratics are your ax squared plus bx plus c. So if you have a factor problem, you end up with just a polynomial. Okay, so you could see a problem like x squared plus 11x plus 30, and the directions would say factor. So in this case, you're asked to break this down into the multiplication problem. What was multiplied to make this? Okay, so we know that our quadratics typically factor into two binomials. So x squared is x times x, and 30, we have a couple choices. We have what? 1 times 30, 2 times 15, 3 times 10, or 6 times 5, and we're trying to make this 11, so the only way to get it is going to be with the 6 and the 5. So 6 and 5, and so this is the factorization for x squared plus 11x plus 30. So if I were to, remember that word FOIL, if I were to FOIL these, I would distribute the x, remember distribute means to multiply, and then I would distribute the 6, remember that means to multiply, and then you should notice in the middle you've got these like terms, and so that's how you double check those to make sure that you got them right. Okay, so what's the difference between factor and solve? So if I ask you to solve this, solve says that you got to have an equation. Okay, this one's not an equation. There's no equal symbol. But if I take that same exact problem and I make it into an equation, then I can solve it, and I solve it by factoring. So I take this polynomial, trinomial, x squared plus 11x plus 30, and I factor it. So we already did that part. I'm just going to rewrite it. And then I use something called the zero product property, which says that these are factors. Factors are things that are multiplied together. It says that if I multiply these together and I get 0, then either the first one's 0 or the second one's 0, because when I multiplied them together, I got 0. So now I have two linear equations, or two little basic equations, and I can solve those. So I will get the x by itself, and as you can see, okay, so here the answer is the factorization, which was x plus 6 times x plus 5. But here the answer is the solution, which means what are the values of x. And so x was equal to -6 or x was equal to -5. Because in that case, this side would turn out to be 0. So if I put in -6, I'd get a 0. If I put in -5, I'd get a 0. So that's the difference between factor and solve. Okay, so the next thing that you have to be able to do is factor all of these trinomials. So I printed a few trinomials, and I want to work on these so we can talk about how to work these. Okay, so this says factoring a quadratic in two variables with the leading coefficient 1. When you take your Proctor knowledge checks, it's not going to give you that title. It's just going to say factor. It's going to look like this, okay? So we know that the answer, this correct answer is correct. This is the correct answer, but how do we get from here to here? Okay, so because we have to learn this so quickly in this class, I think it's easiest to use something called the box method. Okay, so I'm going to turn off my autofocus there. Okay, I'm going to make a 2x2 box. Okay, and why am I making a 2x2 box? Because I know this guy, this trinomial, should break down into two binomials. Okay, so now you'll notice that I have right here, 1, 2, 3 terms, but I have 4 boxes. Well, the first term's going to go in the top box, first box. The last term's going to go down here in the last box. And then this middle term right here has to be made from these two boxes right there together. So I have to make a negative 14xy using these two boxes. Well, since it's an xy, I know that I have to have an x and a y in those two boxes. And so the next question is, how do I break it up into negative 14? Well, there's a lot of ways to break that up into negative 14, but I have to have a specific way. Okay, so this is where you come back to your trinomial and you look at the leading coefficient. This number right here in front of the x squared is called the leading coefficient. So you look at the leading coefficient and you look at most of the time we call it a constant back here because there won't be a variable. In this one there's a variable, that's fine. That y squared is going to come back because we've got y times y and y times y, it's going to make that y squared. So it'll work out nicely. We're not going to worry about that right now. So we're going to use this number back here. So we take those two numbers and we multiply them together. So 1 times 33 is equal to 33. And then we have to break down 33 to get a negative 14. So the only way that I know of to get a 33 is either 1 times 33 or 3 times 11. That's the only way. Now this 33 right here is positive. So how do I get positives in multiplication? Well, I could either have a positive times a positive, right? Or I could have a negative times a negative, because a negative times a negative still makes a positive. So I could either have a positive times a positive times a positive, or a negative times a negative. Okay, so then once you've got your factors down there, you have to find the fellas that make your middle term right here, this negative 14, and obviously it's going to be those guys. So my diagonal right here becomes a negative 3 and a negative 11. Remember, I used the xy because the middle is xy. It doesn't matter where you put the negative 3 and the negative 11. Okay, so now from here it's super duper easy. You just look at the columns and the rows and you look to see what they have in common. So column, I have an x squared here and a negative 3xy. They have an x in common. Column, I have a negative 11xy and a positive 33y squared. So obviously they have a y in common, but they also have an 11 in common because 11 goes into 33. And because it starts off with a negative, this first one's a negative, I need a negative right there. So what do they have in common? A negative 11y. Okay, so now let's look at this row. So what did these two terms have in common? They both have x's. Okay, and that's it. And what did these two terms have in common? Well, they have y's in common, and they also have a 3 because 3 goes into 33, so they have a 3 in common. And it starts off, this row starts off with a negative. Okay, read it from left to right like normal. And so I need a negative, and it would be a 3 and a y. So now you have just factored. So here is your first factor. And here is your second factor. And that is how this is the correct answer. Okay, factoring using the box method. I love this method because this problem had a leading coefficient of 1, but this method works for all of them. So let's find one that does not have a leading coefficient of 1. Let's see if I can find an example problem. Now this one was just a factor problem. Let's go ahead and jump to a solve problem. Okay, so don't stress out. All of these are kind of going to work the same way. Directions here say solve. I know it's a solve problem because it has the equal symbol right there. Do you see it? Okay. So I know in the end I have to get u equals the degree. That means the highest power here is 2. So I should get 2 answers. If this was a 3, I should get 3 answers, and so on. So I can't work these equations like this until I get them in what we call standard form. Okay, standard form is ax squared plus bx plus c is equal to 0. So I need my polynomial on one side equal to 0. Now since this 4 is positive, I'm going to leave him alone, and I'm going to work on getting this guy to come over here and this guy to come over here. That's easy. Just use the inverse operation. So add 12u, and then inverse of minus 5 is plus 5. So add 5. And so now a negative 12u and a positive 12u and a negative 5 and a positive 5 is a 0. That's what I needed. And then on the right hand side I have 4u squared plus 12u plus 5. Okay, so now I see that I have a trinomial, so I'm thinking box method, but first I need to check for a greatest common factor. Does it have a greatest common factor? How do I know? Well, I look at the variables. I have a u squared, a u. This guy does not have a u. So there's no variable that has a GCF. So let's check the numbers. So I'm looking for something that goes into 4, that goes into 12, that goes into 5. Can I think of things that go into 4? Well, 1 and 2 and 4. 12, what goes into 12? 1, 2, 3, 4, 6, and 12. What goes into 5? Only 1 and 5. So the only thing they really have in common is 1, and we don't consider that a greatest common factor at this point. We don't need it, okay? But technically, they do have a greatest common factor of 1. So since there's no GCF, we're going to go ahead and jump to the box. All right, so here's my box. And I know that I put the first term in the first box and the last term in the last box. And now this plus 12u, I'm going to break it up into these two boxes. So how do I do that again? Okay, remember I take the leading coefficient and the constant and I multiply them together. That's a positive 20. And so now I need to write down all the things that can multiply together to make 20. 1 times 20, 2 times 10. I could stop there. 4 times 5. That's all I think of. Okay, so now I need to make a positive 12. And since this is a positive, remember I talked to you about this earlier, they can both be positive or I could have them both be negative. But that's not what I want because what kind of 12 do I need a positive? So these guys are no good for this problem. So the only ones that are going to make that 12 are going to be the 2 and the 10. And then what is my variable in the middle? It's a u. So I need a u here and a u here. And my two numbers that I need are a positive 2 and a positive 10. Okay, so now we go column, column, row, row, and we look to see what they have in common. Okay, so 4u squared and 2u, well, we've got a common 2 because 2 divides into both of those. And then they both have u's, and so u is my greatest common for this column. My next column, I've got a 10u and a 5. Well, 5 goes into 10, so and 5 goes into itself, so they have a common 5. They don't have a common u because they don't both have u, okay? And the leader's positive, so I need a positive right there. So now let's look at our rows. So 4 and 10, what goes into 4 that also goes into 10? Well, a 2. And then I've got a u squared and a u, so they both have a u, so they have a u in common. And then let's check down here. Okay, what goes into 2 that also goes into 5? They don't have a common u. So that's where that common 1 comes in. Because the only thing that will go into 2u and into 5 is 1. So you have to find something in common between the 2 columns or the rows. And if you can't find a number other than 1, you have to use the 1. Okay, so there's my factorization. So here's my first factor, 2u plus 5. And here's my second factor, 2u plus 1. Now I'm going to just verify that for you. I want you to see that it really is true. So remember, it's the FOIL. So I take the first one and I distribute, which means multiply. 2u times 2u, 2u times 1, distribute or multiply. 5 times 2u, 5 times 1, the 2 in the middle are like, add them together. Okay, so I definitely got my factors right. So I know these are the factors. But remember, this was an equation, and we have to solve it. So I take my 2 factors, 2u plus 5 and 2u plus 1, and I set them equal to 0. Remember that 0 product property. It said if I was multiplying, then either the first one is 0 or the second one is 0. And now I have 2 linear equations that I solve. So my first step is to subtract 5 to get the u by itself. Now I divide by 2. And so there's my first solution. On this side, I would subtract 1. You always add or subtract first. And then I have to divide by 2. Oh, sorry, u. That's a u. And there's my second solution. So the solutions, it says solve for, if there's more than one solution. So I do have 2 solutions. So when I submit those, I would do like -5/2, comma, -1/2. And that's what I would put in my answer box in ALEKS.